First thing to keep in mind is this. We have two separate pathways, one for urinary, one for reproduction in females. We're going to have the urethra and the vaginal canal. Males only have one common pathway. You gals have two. After you get that absorbed, realize the position, the relationship between the uterus and the bladder. And do work on this. I every once in a while get someone who gets them a little mixed up. The uterus is on top of the bladder, right? Which is why when you have a 12-pound baby and 20 pounds of amniotic fluid, you have to pee every 20 minutes, right? And we have a picture to let you kind of see this a bit when it's really distended. All right, so let's go over the ligaments that you guys did very well on. To help keep my uterus in place, I need lots of support for it. There's no musculature directly connected to it. So we're going to have a really broad swath of a ligament, which is why it's called the broad ligament. Goes all the way across up to here. And then I notice it's the same color up here. It's the same tissue. But since it's kind of cordoned off, kind of like the caudate and quadrant lobes of the liver, they give it a name. They're going to call it the mesovarium ligament. So that at the broad, I have the mesovarium. Then I realized between the uterus and the ovary is a ligament, and we might as well call it an ovarian ligament. That works really nice. But there's another ligament. So realize the ovary is kind of like just suspended, just held right next to the uterus. It's not a part of the uterus, nor is it really a part of the fallopian tube. So how can I stabilize my ovary? Well, a part of it is held in place by the broad. A part of it is held in place by the mesovarium. I'm connected directly on one side to the uterus, and then there's this ligament here that has two names. The more technical one is the infundibulopelvic, and I think McKinley calls it the suspensory ligament, which is the same thing.
Which one?
Suspensory is the infundibulal.
Which one would you like us to use?
Whichever one you can remember. I usually always give you choices. I'll make you the more common one, but you always have a choice.
Okay.
All right, then I can look at, well, we'll leave it at that for this, other than this little comment. Do realize that your fallopian tubes, your uterine tubes, your oviducts, all the names they have for it, are not really directly connected to the ovary. That would give you the impression that they are. They're not. This is a better idea, but even then, that gap is really ginormous, but it's better than thinking that they're actually connected. There is a space there. All right, let's cut a wedge out of the uterus and cut the fallopian tubes in half so I can see internally. Like your heart, we have a peri, a myo, and an endo. But instead of calling it cardium, we're going to call it myometrium. So we have the perimetrium, the outermost layer of the tissue. We have the big, thick muscle layer known as the myometrium. That's the one that, what's that hormone that comes from the posterior pituitary that triggers uterine contractions?
Oxytocin.
That's where oxytocin will activate. And it's the one that creates the force to, that's what I'm trying to think of, parturiate the birth, to get the baby out through the vaginal canal. And it's a big, thick muscle. So how big is this goofy thing? Go to the fruit stand, find a nice, good average pear. Shape and size is a good model, right? Now, put a 12-pound baby in that pear, right? Yeah, that's like, no thank you. I'm very much helpful to have an XY chromosome, right? I do not want to have to do this, right? That's why one reason women have a higher pain tolerance than males do in that context. Now, outer is the peri, the myo is the thick muscular layer, the endometrium, of course, is the inner layer. That's the one that is shed during menstruation. All part of it is. We'll divide the layers up in a couple of slides from now. It actually has two layers that we'll get to. Now, if I look at this whole big structure, we're going to realize in a couple of slides that there's actually two parts to the uterus. There's the uterus itself, the body proper, and then the cervix. But the cervix is the part of the uterus that actually protrudes into the vaginal canal. So it's only about an inch in size. So the portion that actually goes into the vaginal canal is the cervix. So just this part would be the cervix, right along through there. And and I can see there's a hole on the outside. That's what Oz refers to. And just to avoid future grading scenarios, it's OS, not OZ. All right, Oz, no. All right, it's an os, which means opening. This opening faces the vaginal canal. It's the outward opening, and this Oz, it's a little harder to see, but it's one facing the uterine cavity. It's sort of where the uterus begins to flare back outwards a little bit, sort of the end of what we call the isthmus, the narrowing, the neck portion of our uterine structure. And then we're going to have a canal between the external Oz and the internal Oz, and since it goes through the cervix, let's call it a cervical canal. It goes right through here. What I forgot to mention, and since I just now remembered I forgot to mention it, to the first slide, I'll say it now before I forget. Used to be a really good website. I think it was called My Beautiful Cervix. Where a woman photographed her cervix every single day of her cycle. It's actually pretty interesting.
That's cool.
All right, I'll see if I can, if you send me an email to ask me for the link, I'll search and post the link for you guys on Cannabis. It's actually very interesting. You get to see the change in mucus viscosity inside, so we're going to talk about it in the lecture. All right, so I have the cervix, I have the uterus, I have the body of the uterus, I have the fundus. So you can kind of just maybe draw a line right through here. And, well, actually, since they're making this a chunk of it, so let's just do this. This would be the fundus, all up in there. And there's a cavity in the uterus, let's call it the uterine cavity. Let's go back to the earlier slide. I forgot to point out something to you guys. I can see my uterus sacrals. And so what I would tell myself is, I recognize the names, uterus and sacrum. Okay, so now how is it going to get to the sacrum? And I realize that this is kind of the neck region, sort of where my isthmus is. And I realize that these ligaments are coming off of that, and they have to go to the sacrum. We're still missing one ligament on here. Does anybody know what it is?
Round.
The round, which we'll get to in a moment. All right, let's talk about some of the functions of the vaginal canal. One, reproductively, deposition of sperm. We are internal fertilizers, not external fertilizers. It's also a canal for the birthing process to go from the uterus to the external world, so it is a birth canal. Right? And an exit for menstrual fluid. But to really appreciate, if you ever guys have had a chance to see an actual birth, watch one, right? It is an amazing experience. And you realize that the opening of a normal vaginal canal is about my little finger. And you pass a child through that, right? The vagina is not a very thick tissue. It has the ability of expanding quite a lot. It's only 4 inches long and can dilate to probably about that big around to watch the head pass through. And then it recoils right back down again. It's an amazing bit of tissue. Why can it do that? Because of the rugae, right? Those little expansion folds that are in there. And it'll be lined with stratified squamose. It's non-keratinized. It'd be pretty hard to tell an esophagus, I think, from a vaginal section if you didn't see folds. Just look at the actual stratified squamose part. I think I have a hard time telling which was which. All right, the uterus itself, we mentioned, is small and pear-shaped. Again, go look at a pear in the fruit stand, and it'll be a reasonably good representation of it. There's lots of positions of the uterus, and there's a slide that I thought were in your notes that are not, that I'll put up as a ancillary slide in the future. But the two more common ones are an anterior-posterior tilt. So they're called anteflexion and retroflexion. Let's stop there and go look at a picture of them. That's these guys. Anterior flexion, posterior flexion. Both are self-correcting, especially if you become pregnant. The size of the embryo and fetus will just make it flop back to its normal position in that context. Not really a big deal. But since we're here, and since I don't have that slide that I thought I had in there, it had 6 different orientations for you, which you're not going to have to memorize. But there was one that showed where, if I look at this and I realize the different ligaments, right, that are involved in keeping the uterus in place. You have this image to help you look at it as if you're looking down into the pelvic cavity. So the stomach would be up here, right? There's your sigmoid colon, right? The ascending colon would be up here. Looking down into it, there's the fundus. There's my fallopian tubes, my ovarian ligament, my suspensory ligament, otherwise known as the mandibulopelvic. And there's my round, coming from the fundus and the base of the fallopian tube, kind of coming a little more anteriorly, because this is posterior, this is anterior. And how do I know that? Well, first of all, it says that. But I know the bladder is anterior, I know the rectum is posterior. Now imagine what's going to keep the uterus in place is the contribution from all of these ligaments holding this organ in place. And if you stretch those ligaments out, if you tear those ligaments, I can envision how if I lose all the support of this structure, you see where I'm going with this? It can suddenly just plop right on down through the vaginal canal and all the way out.
Oh, God.
AKA prolapse uterus. I've never seen one to that extent, never seen one period, but I do remember my freshman year at SMU in my regulatory physiology class, taught by an MD, came in one day and said, we're skipping a year, we're going right to reproduction, because he had a patient who walked in that day, and she walked in knock-kneed, and she walked in like this. And she didn't walk that way, and he knew it. Why are you, and then she just stood like this, and plop, she caught her uterus. It fell all the way out.
What?
She had 12 children.
Totally out on the floor?
Totally out, caught in her hand.
Oh my God.
All right. Because remember, this is what's keeping your uterus in place. Are all these ligaments.
I would have shit myself right there. I mean, like, so she just skipped 2 minutes.
Well, that's why she went to the doctor. She said, this thing's dangling. Her
Oh, so
uterus is half out of her vagina.
oh, like she has, there's a ligament still attached to it.
Yeah.
Okay, but she knew something was hanging out, so she's like, oh, let me just.
Yeah.
How could that get out?
Well, again, look at all the ligaments. If you tear them or stretch them out.
Like,
So having kids can really.
So,
do
has
that.
anybody here been on a farm?
Yes. Yeah.
You helped calve?
A little bit.
Ever had a prolapsed anus from a pig?
Not that I've seen.
Ever had a prolapsed uterus from a cow?
Not that I've seen.
The uterus actually infolds and comes all the way out. And you have to push it back in. And then sew the vaginal lip so that it has a chance of anchoring itself.
But just what kind of activity could?
Well,
But
for
just-
the cow, excessive contractions and pushing and forcing. For you, it's simply having 12 children, right? That's a lot of stress on this thing.
Yeah. Okay.
Oh.
So the cardinal ligaments there is also lateral ligaments? Because on the other slide you said
And
round
we're
lateral
not-
uterosacral?
Yeah, we're not worried about those guys. The uterosacrals are these guys.
So which one, you said on the other strip, round lateral uterosacral? So which one do you mean by lateral on that slide?
Well, that's those guys,
Okay.
which we're not going to even worry about. We're going to skip them completely. But now I can see how that kind of makes sense. I lose all support, and remember, the cervix is a part of the uterus. It's already in the vaginal canal. You just come down, just give a little nudge, and it'll slide right through. Right? There's no muscle layer here. Right? There can't be. Otherwise, how does sperm get up in there in the first place? So here's a side view of it. Again, you can see how it would be able to pass through the vaginal canal. But also, I put this in here only because it's one of the somewhat decent lateral views of the round ligament. So you can see that, you know, becoming here and going to the front. It gives you the impression that it's going to attach to the inside of the abdominal wall. It doesn't. It comes out and passes and attaches to the labia majora. So this, I found, is a much better view of it. 9th month in gestation, you can see how large the uterus has expanded, but the stress that creates on what is normally a little round ligament creates a lot of, as I hear, abdominal pain and twinging, because you keep stretching that ligament out. But also, what's this thing right here?
Where your stuff.
What is this?
Bladder.
That's the bladder,
Okay.
right? Right underneath this big thing, right? And then look at all the organs.
That's why when I
Right?
sneeze.
They're
sneeze.
pushed up and back, so it's hard to breathe, it's hard to eat, it's hard to be comfortable. You know, and the comment I've always heard from friends that have been pregnant and even TV scenarios is, you know, you're a beached whale. It's just really uncomfortable the last couple of weeks. You can't be on your stomach, you can't lay on your side, the damn thing's kicking. It's doing trampolines on your bladder. You know, it's just a little miserable existence, right? All right, the uterus itself has the main body part, and it has the fundus, which is right on top of the uterine cavity, which is why I put it in this fashion. I know there's a narrowing of the uterus, hence the isthmus portion, just like there is for a fallopian tube, which means the narrowing. Now we'll do that one later. All right, so for the cervix, I know it's got 3 parts. We already saw them, but if I go from the uterine cavity, right, downwards, I'm first going to come across the internal laws, then I go through the cervical canal, and then I exit, right, through the external laws. So the vaginal canal will be right down here. And we'll talk a little more about what they are involved with probably Monday next week. I think we'll get to it on Wednesday. We might.
John, did you give a summary of the function of the uterus? The,
Where do we have that?
it was the act. On slide 7 on my notes. That one.
On slide 7?
Back.
Oh, right there, that thing.
Yeah,
Yeah,
like a summary.
yeah. How about just protection and nutrients? Oh, to protect and nurture the developing offspring.
Okay.
I mean, first it's going to be an embryo, then becomes a fetus, but it's a, I jokingly call it room and board. All right, because that's what it is. You have a place to live and a place to be fed, right? Until you're able to sustain and live on your own, right? And I tease my animal behavior students. I call us tiger bait, because we're pretty pathetic for the first 10 years of our lives.
That's right.
You know, out in the wild, most of us are. You know, they wouldn't survive. You know, chimpanzees on its own by 5, maybe 6. We take a long time to develop and to maturate, on average. All right. So, uterine lining, as we already mentioned, the parametrium, myometrium, the muscular layer. But the idea of the endometrium has 2 layers, one of which you should recognize. But you have to go back to Bio 241. You have to go back to the integumentary system, to the epidermis, and the 5 layers of the epidermis. And what is the most lowest level of the epidermis called? Stratum basal. And what did the stratum basal do in the epidermis?
It made
From
new
stem
cells.
cells.
Make new cells. This is the exact same thing. It's the bottom layer. It makes new cells. So it's like, good, I get to use that same knowledge all over again. Why is it making new cells? Because of the top layer called the stratum functionalis. Stratum means layer, so I got that, but functionalis, oh, it's the functional layer. It's the layer that responds to hormones. It's the layer that is shed during menstruation. That's why it's called the functional. It's the one that's lost. And if you lose it, you got to replace it. So that's what the whole purpose of the stratum basal is going to be, is to replace those shed cells that we talk about. And within that layer of this functional zone, we're going to have a spiral artery, because it's literally spiral. The next picture will show us that. A bunch of uterine glands for nutrients and mucus, and a straight artery. So it looks a little bit like this. Now, there's the parametrium. You always want to get your bearings. And there's the thick myometrium. And they went to all this nice pleasure to show us this endometrium, but then they didn't bother to actually show you the 2 separate regions of the thing. So in your mind, divide it in half, just right down the middle. The part closest to the muscle layer, the myometrium, is the stratum basal. Therefore, the layer facing the uterine cavity would be the stratum functionalis. And if we look at that division right down the middle, I can see that the stratum functionalis will encompass these uterine glands that provide nutrients for the developing embryo, but also just nutrients and some mucus. But when you get menstrual cramps and the pain, we hypothesize and understand it comes from the literal ripping and tearing of these spiral arteries as that layer sloughs off. It doesn't come off in sheets. I know it's kind of a weird analogy, but have you ever seen sheep molting and the patches of fur that come off the sheep?
Yeah.
That's what's happening inside, right? It's not like a piece of wallpaper peeling off. It's a patch here, and like a sunburn in a sense, right? patches will slough off, and as they come off, they tear the spiral artery, creating discomfort and pain. You'll get about 70 milliliters on average of discharge. And if I look at this, if I just simply zoomed in right here, and that's all I saw, I would go, oh wait, that looks familiar. That could be an arcuate artery of the kidney and a cortical radiate for all I know. It's the same basic design, right? An arcuate artery and a radial artery coming off of the arcuates. Somewhat similar in concept. They're just not called cortical radiates. But the radials become your spirals. Come on, why are you dying on me? You're getting too far away? All right, the fallopian tube, the oviduct, the uterine tube is not connected to the ovary, so I literally put a space there so that we would skip that and realize there is a gap between the actual ovary and the fimbriae. Now these are finger-like projections, so let's come back to this. That's these guys. And they literally create a current of fluid, a beating motion, to sweep the ova into the fallopian tube. Because as I said, these guys are not connected. And there's a chance that the egg that's released, like my little red light, if it doesn't get caught in the literal current, might end up floating around and attach out here, or move around and attach somewhere way down over here. So I want to make like a suction cup in a sense, or some fluid currents, and draw it into the fallopian tube. Now, if it doesn't go in the fallopian tube, it stays outside anywhere and attaches to the uterine tissue or the fallopians. What kind of a pregnancy do we call that? It's an ectopic pregnancy. Now, it can also happen in the fallopian tube, right? It simply means it's not in the endometrial lining of the uterine cavity. And that's why the importance is of realizing that A, they're not connected, and B, the need for the fimbriae to create a sweeping motion to draw the fluid up and get a current going to catch the ova as it then is released. The other idea, come on, why you are dying on me here, is the infundibulum at the base of the fimbriae. If we go look at the picture of the ampulla, we're going to go backward. Let's go to the fundus of the uterus. And there's the beginning of my tube. It's long and narrow, and that's the isthmus. It's about a third of the overall length of this. When it begins to widen, then we call it the ampulla, because we're going to have the same structure in a male, where it's just going to be the widening of that tube. Most fertilizations, come on, you're driving me nuts tonight. You're being a pain, time to go buy a new one. Most fertilizations happen in the ampulla. That's about where the egg will come in contact with the sperm come in contact with the egg. So the fimbriae help to draw the ova into the fallopian tube by creating a current of fluid. The ampulla is the location of fertilization events on average. And they can happen anywhere, but that's usually where most of them do it. Come on. This is a cross-section of your uterine tube, fallopian tube, oviduct. And if you give it a quick glance and looked away, it should look somewhat familiar. Like an esophagus almost, right? The basic pattern of folds of tissue. And what I want you to think about is in a three-dimensional structure idea, right? This lane, this lumen coming this way, because there's a big chunk of tissue coming out like this, another big chunk of tissue coming out like this. So on the outside, I really wouldn't notice the individual separate lanes. But if I'm on the inside, and what if the ova was traveling down this lane on this side, right? And the sperm were coming up this way in this lane. It's like you driving in the southbound lane in the Los Angeles freeway and you're on the northbound lane, right? You gotta pass by each other. You're not in the same lane, right? You have to be in the same lane for the two to come in contact with each other. So again, it's another thing that's really interesting that I'm surprised you get pregnant, period. Because when we back up and look at this, so there's all these lanes that are in here, which are these designs right here. We'll talk a little more next week how we're looking at a lot of sperm coming in the vaginal canal, having to pass through a mucus barrier. Well, there's one big problem with the vaginal canal. It's really acidic. That's both a good thing and a bad thing. It kills a lot of sperm. Whoever survives is going to go up the cervical canal and get into the uterine cavity. The uterine cavity, the wall of it, the endometrial lining, stratum functionalis, is not a nice little flat, smooth surface. It's got full of cracks and ridges and nooks and crannies. And sperm get wedged in those. And sperm don't have reverse. You get stuck in that drift, you're going to die there. You're going to get atrophied. Okay? Well, here's the other thing, right? So you got X number of sperm coming in here. You didn't get killed by the pH, that's nice. You made it through the gauntlet of mucus. You got into your uterine cavity and weren't dumb enough to get stuck in a wedge or a nook and a cranny. And then I come up here and going, oh crap, there's a fork in the road. Do I go to the left or go to the right? Half will go the wrong way, statistically, because guys don't ask for directions anyway. Right? And if you do get up in here, right, now I'm a sperm cell traveling, I hope to God, in the right lane, right? I hope that she's in here and I'm in here. She's going out and I'm coming out so we can crash into each other. But if I zoom in on the actual floor of my highway,
Cool.
it's this. And this is not a close-up of my carpet. These are cilia. And they're creating a beating motion to help carry the ova down the fallopian tube, creating a stream for the egg to ride with. But what are these big little things?
Sperm?
No. Sperm's worst nightmare, actually.
Macrophages?
Yep, white blood cells. They are there to eat, munch, crush, kill, and destroy. So one way to think about it, in kind of a comical sense, but also a true sense, the female reproductive system is designed to be as lethal as possible to sperm. Only the best survive. Only the healthiest will get to the actual egg. You don't want lazy. There's lazy sperm. Right? There's sperm that have two heads that swim in circles. Right? I don't want those to fertilize my egg. Right? And you'll have sperm with 2 or 3 tails that also swim in the zigzag circle pattern. Right? We'll look at those guys next week. Last little bit, the ovaries. What is their function? To produce gametes. What are gametes? Let's tap into your 211 experience. What are gametes? Eggs and sperm. Alright? So I hope you guys realize ovaries produce which part of that combination? Just the egg part, not the sperm part.
Man, we'd be cool for that.
Well, we'll talk about that in next week. How gals don't need guys. Okay? Now, remember that they are haploid, which means they have one version of each chromosome. Here's how you really shouldn't say this. So, haploid, John, I'm going to have my Bio 160 students on the final describe what haploid means. And they're going to say, it's half the number of chromosomes. And you go, nope, sorry, wrong. Because you mean what, 1 through 12? I throw away the rest? No, it's one of each type of chromosome. 1 through 22 plus an X and a Y. Right? You have one of each.
An X or a Y.
Right, X or Y. Well, you could get an XX and a YY, but that's not normal. Right? And that's the function of the ovaries. Those hormones we'll talk about Wednesday and all next Monday. See, that was easy, because A, you already knew most of it. Right? And maybe you study on your own.
That was
Right?
I like that.
Now, why did I make you guys do it that way? 1, because we're short on time, but 2, that's how a lot of your learning is going to come in the future. They're going to say, here's a book, here's a list, get to it. Right? And the more I can help you learn how to do that, the easier it'll be for you in the future. And it wasn't that hard to learn those.